This talk introduces ConvoKit, a new Python toolkit for analyzing conversational data. Conversations are quite diverse, ranging from online conversations like social media to offline conversations, both institutional and informal, and even to fictional conversations like movie scripts. So clearly, conversations can vary wildly in terms of the contexts, settings, and formats that they take place in. And yet, despite this diversity, there are also some key unifying properties that are shared by all conversations. One such unifying property is that conversations are structured. That is, the utterances in a conversation cannot be treated as standalone documents. Instead, we must also consider how they relate to each other. For example, who replies to who and when replies are uttered. Second, conversations are inherently social. That is, the interpretation of a conversation depends on the people within it. For example, an utterance that might be considered rude by one audience might be unobjectionable to a different audience. Unfortunately, the current state of conversational data does not directly reflect these key unifying properties, and this can pose barriers to running the kinds of interesting analyses that we as scientists who study and model conversations might want to do. To see why, let's consider some concrete examples. One problem that immediately arises is that there is no universal standard for how conversational data should be represented. As such, some datasets are formatted as simple CSV tables, while others can take on a more complicated format like this list of JSON objects. This poses challenges to generalizability, as code written to analyze one dataset may need to be heavily rewritten to analyze a different dataset. Furthermore, limitations of these text-based formats restrict the extent to which they can represent the rich structure that conversations have. Of course, datasets often provide pointers to reconstruct that structure, such as the ID and parent ID fields in this JSON object. However, actually using this data to reconstruct the structure can require writing quite a bit of boilerplate code, which takes time away from the actual analyses that we are interested in. As such, it appears that there are two missing ingredients needed to streamline conversational data analysis. First, we need a unified representation of conversational data, and second, we need a general language to describe manipulations of that data. Providing both of these missing ingredients is exactly what ConvoKit aims to do. Now, let's look in more detail at how ConvoKit achieves this.
So what does this unified representation look like? Well, intuitively, conversations, or discussions between some group of people, are simply some sequence of utterances, where each utterance is made by some speaker. And so in ConvoKit, we represent conversational data using these three concepts: conversations, utterances, and speakers, and each of them are first-class data objects in ConvoKit. A collection of these components is what we call a corpus, which basically represents the entire conversational dataset. Now, as first-class data objects, each of these components shares a consistent data format. Each of them has some set of primary data fields, such as ID, and each object has its own metadata, which is where we will encode additional data attributes, such as predictive features and labels. Now, one really nice thing about the ConvoKit hierarchy is that the data objects are interoperable, meaning it's easy to navigate from any one component to any one of the other two components. And so it's easy to do higher level analyses, like track a speaker's behavior across all the conversations that they've participated in their lifetime, or characterize a conversation by the composition of its utterances or the speakers that have participated in it. In addition, each of these objects have their own methods and functions, which makes them really powerful for all sorts of analyses. So for example, we discussed the problem of encoding conversation structure. Well, in ConvoKit, conversation structure is automatically encoded, such that for every conversation object, you can automatically access its structure and even traverse the conversation tree in interesting ways, like a breadth-first or depth-first traversal. So now that we have these data objects, the question is, how do we do higher level analysis with them? And so now we introduce the concept of a transformer, which at a high level takes in a corpus and applies some sort of transformation or modification to it. And these modifications usually come in the form of changed or added metadata for one of the corpus components, meaning its utterances, speakers, or conversations. Now broadly, these transformations come under three categories: preprocessing, feature extraction, and analyses. and we now quickly run through a few examples of each of these. So for preprocessing, for example, you might use our text parser transformer to annotate the utterances within the corpus with their dependency parsers. You might use the text cleaner transformer to locate and remove any Unicode from the text for all the utterances within the corpus. For feature extraction, you could use something like hyperconv, which represents conversations as graphs and computes graph-related statistics, and then annotates the conversations with these statistics. Or if your corpus already has dependency parsers for its utterances, you could build on it by using politeness strategies, which uses these parsers to identify linguistic devices that indicate politeness. Finally, for analysis, you can use something simple like ranker, which lets you rank some of your corpus components according to some arbitrarily defined metric. For example, you might rank your speakers by the number of utterances that they've made. A more complicated example would be classifier, which lets you train any scikit-learn predictive model using the predictive features of one of your corpus components, such as the politeness strategies of your utterances. Now, all transformers are inspired by and conceptually analogous to scikit-learn's own transformers. And they each have a fit step, where you might train or fit some sort of internal model, a transform step, which does the modification of the corpus that we've just described, and a summarize step, which usually summarizes the modifications that have been made to the corpus in some sort of visually interpretable way. And because each of these transformers have a fit transform paradigm, you can combine them in sequence for more complex operations. And so using the examples we just described, you could set up a preprocessing, feature extraction, and analysis pipeline very easily simply by chaining these transformers together. And we even have a ConvoKit pipeline class to facilitate such pipeline analysis. We now move on to a concrete application of ConvoKit, where we examine differences in language in fictional conversations. And here we use movie corpus, a corpus of movie transcripts. And one question that might come to mind is, how do conversations that involve both male and female speakers differ from conversations that involve only male or only female speakers? And for convenience, we refer to these as mixed gender and single gender conversations. And so you might imagine some sort of analysis where we take utterances from both of these groups and then seek to identify salient linguistic differences between these two groups. To do this, we'll use an established method called fighting words, which is also available in ConvoKit. At this point, we're going to make two notes. Firstly, this is an especially interesting analysis because it uses all three levels of the ConvoKit hierarchy, namely conversations, utterances, and speakers. Secondly, a more rigorous analysis can be done with a more nuanced approach to gender, but because of the limitations of the movie corpus, which has only male and female labels, we are limiting our analysis to male and female speakers. So what does this look like as actual code? Well, firstly, we will have to load the corpus. We will use the text cleaner transformer to clean the utterances. And then we do some custom feature extraction, where we label conversations as mixed or single gender. And here we want to emphasize one of the virtues of ConvoKit, which is that it's easy to link components together. And so it's very easy for us to label this conversation based on the attributes of the speakers that have participated in this conversation, which might be more difficult to do in other setups. Finally, we do some fighting words analysis based on these two groupings and find a summary of language differences. And so all these steps comes down to a quick and simple 10 lines of code. And we're happy to run through this example in detail during our live Q&A. This demo is available online in our GitHub repository along with many other examples. In any case, if we run this code, we get this plot, which is very suggestive of differences between these two groups of utterances. We see that mixed gender conversations have more terms of endearment, like love and honey, or single gender conversations have more male terms of reference, like man, sir, and mister, which perhaps reflects certain known stereotypes that have been discussed in prior work, such as that mixed gender conversations tend to be more romantic in nature, while single gender conversations tend to be primarily between male characters. And so we want to emphasize that it's really quick and easy to set up these sorts of analyses in ConvoKit. And being able to so quickly generate an initial plot like this might be a useful starting point for more rigorous analysis. Through ConvoKit, we've offered a unified representation of conversational data, as well as a general language to describe manipulations of that data through transformers. In addition, we also offer a large and diverse collection of datasets already in ConvoKit format that come with rich metadata and are from a wide variety of conversational settings. Finally, our work is open source and we definitely welcome any contributions you may have. In particular, if you have any conversational datasets and methods that you'd like to share with the world, we're happy to work with you to incorporate them into ConvoKit. If you have any other questions or if you'd like to see ConvoKit in action, please join us for our live Q&A. Thank you.